Yes, good morning. This is my first case today. It's let me try to find out the year. According to the 10th digit of the VIN, this is a model year 2000. It's a BMW E46 chassis. Yep, it's a 318i. The complaint with the vehicle is the engine cooling fan is running all the time, and that's what I'm here to investigate. The vehicle was here last weekend to fix something else. What I'm going to do, because the fan is running all the time and it drains a lot of current, so it's very likely to draw the battery, because I wanted to keep the car in key on, engine off condition. But when I do that, while I'm diagnosing using the computer or using the scan tool, but if I do it for a long time, for an extended time, the battery is likely to run down. So what I'm going to do is run the engine and then have a look at a few things on the computer. We already have a problem. The vehicle, the engine won't start already. Looks like we already have a low battery. I don't believe that. I've just parked this vehicle here about 10 minutes ago, and I left the key in the off position. I'm trying to crank it now, but it won't. Hear that?
Just had it.
Jumping man.
Play tennis the way he has to. Remember, Murray is 29.
We're going to have to
jump
jumpstart this
Murray
this
is ranked
engine.
second.
I don't know if you can already hear it.
Raonic is seventh.
Already is playing, but if you can hear it, if you can listen, the cooling fan is already running with the key in the on position. So let me get the engine to run first. Okay, we've jump started the car. The customer is aware that he has a bad battery. So I want to check a few things. First of all, I know where I need to go to do checks on the engine cooling fan. I have some knowledge about how it operates. What I'm really doing here is trying to find out if the ECM, engine control module, is already aware of any issues with the engine cooling fan circuit. This is a BMW. I'll use the latest version of the software, and I'll also turn off the air conditioning for now. It's going to be a hot day. It's about 10 o'clock in the morning. It's already hot. I bet it's approaching 30 degrees centigrade already. So in a few hours it will be much hotter, and this guy needs to use the air conditioning. The air conditioning actually seems to be working pretty well, so the issues seem to be solely with the engine cooling fan, which is shared with the air conditioning. The condenser uses it too. This is the E46 chassis, and I want to go into the drive. I want to speak to the engine control module, check for codes. Right, we have related codes related to the engine cooling system. One, it says engine coolant outlet temperature. I think that's the temperature sensor. Activation map cooling, that would be for the thermostat. On this vehicle the thermostat can be opened electronically by the engine control module regardless of the temperature of the engine. Oxygen sensor control, limit, blah blah blah, signal camshaft position sensor, those are not related to the issues. In fact, these codes are looking like they are past codes. I'm going to take a snapshot of these codes. I already know what they are because I'm recording on the video, but what I'm going to do now is, because I'm not sure, this vehicle has been to several garages already, I don't want to be chasing these other codes, 3135 for the camshaft position sensor. The engine starts and runs well. Oxygen sensor control, I don't want to go into that now. I don't feel any misfires on the vehicle, etc etc. I just want to go back to, I want to erase codes actually and see which codes come back immediately, and I want to see if any codes related to the engine cooling fan pop back. Okay, we still have one for the signal coolant outlet temperature, and yes, now we have 108 activation electric fan. So it knows there is an issue with the electric fan, and also it is complaining about the signal coolant outlet temperature. So I'll ignore the camshaft position sensor P0340 for now. I will come back to it. I will inform the customer that is throwing this code, but he brought this vehicle here specifically for the engine cooling fan issues. So I'm going to go investigating this one, 108, and right now I'm going to go into data. Oh, I also need to have a look at that temperature. I said coolant outlet temperature, right? I'll look at that signal. It's getting hot in here, so I'm going to run the AC. I'm going to reduce the temperature. This vehicle actually has climate control, not normal air conditioning. I don't know how well you can see that. So my next step is go to check data. Component activation, I want to see what I can play with. Oh, I can play with the electric fan. Interesting, but it's running all the time, so I can't. I'm going to try to command it off and see if it obeys that command. But to check it out, I have to throw the command and then go out and see if the fan actually slows down. it's on now. I'm going to try to command it off.
Okay.
It doesn't seem to heed that command. Even when I switch it off, it just keeps running. So either the engine control mode is not sending that signal, or if it is sending that signal, the engine computer, rather the fan control module is not heeding, it's not obeying that signal for whatever reason. Now I want to raise codes again. Now I want to read data. I want to read data, specifically looking for engine temperature. Okay, I'll see about the compressor, electric fan. It is saying it is controlling the electric fan at 69%, and the AC compressor is not active. Okay, it is now active. I hadn't actually turned the air conditioning on. So it is now active, and I can feel the change in RPM. That button, I hadn't pressed it. Now the AC is off. It's only the blower motor running. Now the AC is actually off. And it argues here that it has switched the AC compressor on, but it is not changing the speed of the electric fan. I want to have a look at the temperature sensor. Engine work value, is that where it will be? Okay, here and here, but maybe even this one, intake air temperature, to compare. Okay. Okay, it says coolant temperature engine. I think on the block, the temperature is at around 100 degrees. If it stays there, that's fine. But it says for the coolant temperature radiator outlet, it's saying almost minus 40 degrees. Now that tells me that temperature radiator outlet temperature sensor is either shorted, no, open, or either it has an opening is wiring, or the sensor itself is bad, or it's not connected up properly. So I think before I go any further, I'm going to have to find out about that temperature sensor next. And also I'll use I plan to use the oscilloscope to check if the engine control module is actually controlling or sending signals to the fan control module for this to operate. Okay, we have already found a problem with that sensor already. That is this sensor. I don't know if you can see my finger. I'm wiggling it down there. Don't know if you can see it very well, but around where I'm wiggling my finger is where that sensor fits or sits, and this is its connector. And this connector unplugged should have ground on one wire and 5 volts on the other. I couldn't find the 5 volts, and very quickly looking at the harness, I found the wire broken right here. Hope you can see that it's open like that, totally broken, like it was cut totally. You have the ground wire is still okay, but the wire with the that's supposed to take 5 volts to the sensor is broken, and we are going to fix that. And something else, because the battery keeps going flat, we've taken the fan off to get the key in the on position without running the fan, and therefore draining the battery. So that's our first find. I put the multimeter on that broken wire on the end going to the computer, and you can see we have 5 volts on it. So we are just going to repair it and have the 5 volts coming all the way to the connector, and then we shall have a look at the computer data again. Okay, we've reconnected the signal wire to the coolant radiator outlet temperature sensor, and you can see the signal is now reading plausible readings. It is still quite reading low, 37 degrees centigrade, but we've just discovered, I'll show it to you around the front. We've discovered that it has a thermostat here, and this vehicle has been running. This is the inlet into the radiator, inlet pipe into the radiator. This one, and it's very hot. You can hardly touch it. But the inlet into the engine, the outlet of the radiator, is quite cool. I can touch it without a problem. As you can see, it's quite cool. Except this part next to the engine, obviously it's getting heat because of conduction. But what that is telling us is that it has a thermostat, an electrically operated thermostat here, which is stuck closed for whatever reason. It's not letting water flow from the engine through the radiator and back into the engine. That seems to be another problem, and could have been the source of this customer's problems, because issues began when the engine overheated, and whatever garage he took it to decided to service, in quotes, service his cooling fan. But basically, I can tell you the water is not flowing, and that's an issue. That's why the temperature sensor here and the outlet is reading so low, because the water is not flowing in that pipe. But that's another issue. With the engine now running, I've connected my multimeter to the fan socket. You can hear the fan is running full blast. I can see, rather on this socket, I've connected to the signal wire, and I can see some kind of signals because I've set my multimeter to read the frequency of whatever voltage is there, and I can see there's some kind of activity. I'm going to get my oscilloscope out at this time and have a look at that signal. That would indicate that the ECM is doing its job, but the cooling fan module is sleeping on the job. Okay, you can see we have a signal from the ECM to the tap here to the engine cooling fan module. We have a plausible signal. The AC is on right now. I'm going to switch it off, and we shall see that duty cycle kind of changes. So I'll switch the air conditioning off from here, the switch, and go back on the front. And you can see the signal has changed somewhat. In fact, it has gone off completely. Oh, it has even reversed. It looks like for a moment it looked like it had reversed polarity. Yeah, there seems to be something going on there. What I'm going to do now, I'm suspecting because the engine cooling radiator outlet temperature sensor is reading so low, the engine control module is not making any effort to run the fan, but the fan is running all the same. So I'll force it to command the fan by turning the AC on again. And where has that signal gone? I think there's a problem with my connections. The signal is back. I think there was I had a loose connection, but you can see the duty cycle for off is about 20-25% right now. I'm going to turn the AC off. Turn the AC off using that button. And the duty cycle goes way down. In fact, it even disappears eventually. There's something going on here. I didn't expect it to go all the way to zero. Switch it back on. It takes its sweet time, but the signal is there. You can see it's now down to like 10%. It is increased to about 20% now. And then I see those superior signals at the top, which I don't like. But anyway, the engine computer appears to be sending signals to the fan control module to operate on off, and the fan control module doesn't appear to be responding at all. Okay, I'm now going after the map controlled. I'm going after the map controlled thermostat, which is down here, and I'm trying to check the resistance through its coil, because it has a heater inside there which the computer controls. I've already proved it has a good ground all the time, and the ECM controls the power side of the circuit, of the heater circuit, using a duty cycle. Unfortunately, you missed that. I did it off camera, but you have to take my word on it. If I have time, I may show it to you, but right now I'm having trouble connecting to the terminals of the thermostat so that I make the continuity checks. I wanted to show you that I've already done it, but the connection, my alligator clips fell off the terminal. It's a tight, I don't know if you can see what I'm doing. It's a really tight connection. I think I'm going to stop the camera until I have it done, and then I'll show you. Okay, it turned out to be such a tight connection, very difficult to make, so Roger is helping me hold it, and you can see, you can't see the crocodile and the pins, the crocodile clips and the pins, because his hands are covering it, but you can see from the multimeter that we are getting a reading of about 15.5 ohms, which I think is plausible for a good heater for that thermostat. If it's not opening, I think it's the thermostat which is just stuck. It is heated. The way the computer controls is that it's normally closed when the computer doesn't power it up. It has a full ground, which I will show you, and the computer puts 12 volts via duty cycle on the other wire to heat the wax up and open that thermostat. So it looks like the heater is just fine, but for whatever reason the thermostat, the wax and all that mechanism that's supposed to open the thermostat doesn't appear to be working because it is stuck shut. There is no water flowing through that thermostat connection. Now I have the multimeter connected to the ground side, to the ground wire that goes to the thermostat, and the other side is onto the engine block, and you can see I have about 16 ohms. Not a very good ground, but still that is evidence enough that we have full ground on the thermostat. And the next step will be to show you how the computer powers that thermostat by heating the heater, rather by controlling the heater using duty cycle, 12 volts duty cycle. I will move the pin on the connector. I'm now connected to the other wire coming from the ECM, and I'll show you here on the multimeter. Right now you have 0 volts. Actually this should go there too. Even on the multimeter we have close to 0 volts. So I'll go to the computer and command the computer to turn the map cooling on for 30 seconds. It is doing that now. And then when I come back here, you can see it's kind of trying to control it using duty cycle. You see that? And on here on the multimeter, you can see there is voltage playing there. My next or last step should be two last things. When I do this command, I want to connect it to a test lamp to see if it is powerful enough to at least light a test lamp. We could be seeing voltages being read by the multimeter, but they could be a weak voltage, not enough to actually heat that heater. Okay, I'm going to command it again, to command the map controlled thermostat again. I think I have now on. And you can see I have voltage here on the multimeter. Now on the ground, you can see the test lamp is bright. It is actually going on and off, following the duty cycle. This is very nice. You can see the computer controlling the heater, and this I've replaced the heater with the test lamp, and you can see, and it has stopped now because I commanded it to do it for just 30 seconds. So now, unless we have a very bad connector in that, when you push it back in here, it doesn't work. I think we are bothering the ECM for nothing. It is saying here it's not making any effort to turn the map cooling off, to turn the thermostat on. It's not bothered right now. It doesn't. The ECM doesn't want to control that thermostat unless we command it. We just discovered the lock was missing on that connector and we replaced it, and it's raining now, so I can't show you. I can't go around the front and show you the I wanted to use a temperature gun to show you that the water, when we commanded it, when I commanded the ECM to open that thermostat with a fast connection, when we found the missing clip and put it back, that the water is actually flowing through when we command it. So it's not a problem with the thermostat. Thermostat is working fine. The ECM just doesn't want to control that water going through there, the hot water going through the radiator just yet, and the temperature is hanging just about where it wants it to. So we shall stop poking around with that. What this vehicle needs is a new cooling fan, because the engine cooling fan on it now has a bad module. It is running full blast at 100% full speed, even when the ECM tells it to run slower or to go off completely. So all that this vehicle needs is a new cooling fan with a good module. Thank you for watching.